and to watch a full-on scientific film. So now, let us have a look at this model, and let us start with our home planet, with the planet Earth. I'll give some information, maybe some of you should have known this, some of you may not, so, okay. Our Earth is the third planet counting from the Sun, is our home planet, and its age is about 4.5 billion years. The contemporary analysis, based on dating by radio, approximately 4.4 billion years. So, let us have a look at this model, and let us draw a parallel between this model and our planet Earth, our real planet. Let us have a look. What are the differences between this model and our Earth? What are the differences? Who can tell me?
It's smaller.
The size. First of all, size for sure. Yes, it's a bit less. And what else?
Ingredients.
Sorry? Ingredients. Oh, maybe. Okay, originally. What else?
Shape.
For sure, shape. The shape of the Earth is a bit flattened. Yes, a bit flattened on the poles, and this special shape is called geoid. Geo is the Earth from ancient Greek. Okay, and what's about the spinning axis?
Different.
Yes, it's a bit inclined. Yes, it's a bit inclined, and the angle is about 23.5 degrees. It's not so much, but it affects the change of seasons on our planet. So, okay. Now, let us have a look at this model itself, and I suggest you to bend down a bit, so as to see that it levitates. It levitates in the air, it is hung in the air. Do you see it? I'm not tricking you. I can prove that. Okay. So, you must have guessed what's the reason for this odd occurrence. Here's a magnet inside this model. In this model, and another magnet in this platform. As you know, the poles of magnets, they interact, but what's more, this one is connected to power supply, and the power supply, it creates a certain electromagnetic pillow, the electromagnetic field, and this field makes this bizarre occurrence possible. That's why it levitates. Talking about our Earth, the planet Earth, you may state as you want. Again, to swing from one side to another, as I show you with this model. And it began to leave traces on the sand. Initially, at first it was one straight line. As you see, one straight line, yes. But as the time passed on, as the Earth made its rotation around itself, these lines began to change. It was one straight line, and after a time, there occurred some bizarre figures, some strange figures, which resembled maybe stars, maybe some flowers, I don't know. Everyone had some associations according to fantasy. So, it is these figures which helped demonstrate that the Earth really rotates around itself. But what's the principle of this experiment? Briefly, the plane of the oscillations, it remains the same. It concerns such big mathematical pendulums such as the Foucault pendulum. As the place where it is hung, it rotates around itself, and the plane of oscillations remains the same. And that's the main principle why this experiment works, why it helps prove the rotation of the Earth. So now, let us move to our next station, to the solar system.